Okay, in this next video, part 5, we are going to be looking at rational expressions. And this is just a polynomial over a polynomial. Now, anytime we are looking at a rational expression, we have to consider the restricted values, meaning what x cannot equal. Now, no matter what, at any level of math, you can do math through grad school and you'll still never be able to divide by 0. So we always want to make sure that our x values, whatever is in the denominator, won't make our denominator 0. So we can just make a little note here. We can never divide by 0. So x cannot be a value that will make our denominator 0. So when we are talking about what x cannot equal or what it can equal, that's talking about the domain. It's all the possible x values. That's the input to our expression. Range is referring to all of the possible y values. That's the output. So when we are simplifying rational expressions, what we want to do is factor the top and bottom completely and then cancel out any common factors between the top and bottom. When we're multiplying rational expressions, it's the same thing. Factor the top and bottom, cancel out any common factors, and multiply what's remaining. So we are going to do an example of that. And I'll go ahead and zoom in since it's pretty small here. And we have x minus 7. There's no way I can factor that further. X minus 1. There's no way I can factor that further. But these other two pieces I can factor. So I have x minus 7, and I'm going to go ahead and put parentheses around it just as a reminder to myself that that factor, this is stuck together. I can't just cancel out, for example, these x's here that are the same. The whole piece has to cancel together. So on the other side, x squared minus 1, that's a difference of perfect squares. So that'll be x plus 1, x minus 1. And 3x minus 21, there's a common factor of 3 there. Pulling that out, I'm left with x minus 7. And so I can see some common factors here. Multiplying fractions means we multiply straight across, so I can cancel anything in the top with anything in the bottom. Well, I have an x minus 7 and an x minus 7. Those are the same, they can cancel. I have an x minus 1 and an x minus 1. Those are the same, they can cancel. So my answer then, the only thing left up top is x plus 1, and the only thing left on bottom is a 3. So that would be my answer. Dividing rational functions or rational expressions is basically the same. There's only one additional step. So the very first thing you're going to do is flip the second fraction so the bottom becomes the top and the top becomes the bottom. And then it's the same process as multiplication. So following the same process as the one we just did. So again, we want to flip the second fraction. You always flip the second one, not the first one. And I do want to factor these as well. So this first fraction here, since it's going to stay the way it is, I'm going to go ahead and factor it. And I'm not going to show my work for the box method, but that's kind of what I'm going to do here in my head. And I'll end up with x minus 4 and x plus 2. So you can refer back to the previous video if you need a refresher on the box method, but that's just what I did to factor that. And then x squared minus 9 is a difference of squares again. So that'll be x plus 3 and x minus 3. And then again, we're going to change this to multiplication and flip the second fraction. So that x plus 3 goes on top now, and the x minus 4 goes on bottom. And now we can go ahead and see what we can cancel. An x plus 3 and an x plus 3, an x minus 4 and an x minus 4. And all we're left with then is x plus 2 over x minus 3. And you could put the parentheses around it like I did in the previous one, or you can leave it just like this. Sometimes I put the parentheses around it just to remind students that that is a factor that's stuck together. I can't cancel these x's out. The whole thing would have to be the same to cancel. Now, multiplying and dividing is definitely the easier of the operations with rational expressions. Adding and subtracting is a little bit harder. Now, if you think back to like elementary school when you first started working with fractions, or maybe middle school, when you were adding or subtracting fractions, you always had to have a common denominator, meaning the denominator had to be the same. So let's do a really basic one first. If I had, let's say, 3 over 5, let's say 15, rather than 5, I'm going to use 5 over 6 plus 3 over 8. Okay. Well, 6 and 8, we need to find a common denominator for those two. Now, you could just multiply 6 times 8 and use that, or you could look for something smaller. And so what we're going to be doing is, when we're working with polynomials, is we want to factor the denominator. So in this case, 6 is 2 times 3. 8 is 2 times 2 times 2. You could do factor trees for those if you wanted to. And so my common denominator needs to have all those pieces in it. It needs to have a 2. It needs to have a 3. It has a 2 in it already, but it needs 2 more. Well, 2 times 3 is 6, times 2 is 12, times 2 is 24. So that's going to be my common denominator here. Let me zoom out a tad here. So if my common denominator is 24, then what I need to multiply each of these fractions by is whatever would make this 24 and whatever would make this 24. Well, 6 times 4 is 24, so I'm going to multiply by 4 over 4. And we do it on top and bottom because we can't change the value of the fraction. If I just multiplied by 4 on the bottom, that would change the fraction. But anything over itself is just 1, and multiplying by 1 doesn't change the value of this. Similarly, 8 times 3 gives me 24, so I'm going to multiply by 3 over 3 here. And then this becomes 4 times 5 is 20 over 24, plus 3 times 3 is 9 over 24. So my answer then is 29 over 24. So that's how we did it back when we were just working with numbers. But we're going to apply those same processes to working with polynomials. Here I have x plus 3 over x squared plus x minus 2. And here I have 2 over x squared minus 1. And you're already seeing how important it is to be able to factor and factor quickly and do it correctly. Because if you can't factor really everything else we're going to do this whole semester, you won't be able to do. So if you're still feeling kind of shaky on factoring, you really want to practice that as much as you can. Really make sure that you master that. That way, moving forward, you're able to do all of the concepts that we're going to be looking at. Again, I'm not going to show my work for the box method, and so I'm just going to go ahead and write what these factors are. This will be x plus 2 and x minus 1. And for this denominator, x squared minus 1 is a difference of squares. That'll be x plus 1, x minus 1. So looking at these, figuring out what my common denominator would be, I need an x plus 2. I need an x minus 1. I need an x plus 1. And I already have an x minus 1, so I don't need to do another one. Now what's missing from this fraction is the x plus 1. So I'm going to multiply on top and bottom by x plus 1. And I'm kind of squeezing it in there small. You probably can't read that super clearly, but these are both x plus 1. Just like we did over here when we multiplied by the 4 over 4 and the 3 over 3, that's what we're doing here. This one has the x plus 1 and the x minus 1, but it's missing the x plus 2. So x plus 2. Okay. So let's go ahead and rewrite that whole thing. On top here I have x plus 3 and x plus 1. And x plus 3 times x plus 1, you could use FOIL, or you could use, I kept saying the box method here. The x method is what I was referring to in factoring. You could use the box method to multiply those out, or FOIL. I'm going to go ahead and use the box method, but again, I'm not going to show my work for that. I'm going to go ahead and just do that in my head. If you want more practice with that, again, go back to the previous video. So x plus 3 times x plus 1 is going to give me x squared plus 4x plus 3. And I'm actually not going to multiply out the bottom. I'm going to leave it as the common factor or common denominator. And then on top over here, I just have 2, so I just have to distribute the 2 here, and that's going to give me 2 times x is 2x, 2 times 2 is going to be 4, and then again the common denominator. And now that I have a common denominator, just like we saw over here where we had the same denominator and we could go ahead and add now, same thing happens here. So I have my common denominator. I'm going to go ahead and just write it over just like here, 24, 24. Here it'll be the same common denominator. And then adding these, we're just combining like terms. So x squared, well, there's no x squared here. 4x plus 2x is 6x, and 3 plus 4 is 7. Now, if it's possible to factor this polynomial here, we need to do that and check and see if it reduces with the denominator. Just like over here, if I had maybe, let's say 28 over 24, those would have common factors and I would need to reduce my answer. The same thing happens here. So sometimes this is factorable and it will reduce with our denominator. In this case, this is not factorable with the x method, so there's nothing we can reduce here. The last problem on this page is called a complex fraction. And what that means is we have fractions inside of a fraction. Now these always look a little bit scary, but they're actually not that bad as long as you can identify the common denominator. Now looking at all 4 denominators here, in this fraction the denominator is x, in this fraction the denominator is 2, in this fraction the denominator is x, and in this fraction the denominator is 4. My common denominator among all 4 of those needs to have an x, needs to have a 2, needs to have a 4. 4 takes care of the 2, so my common denominator is 4x. And what we're going to do in this scenario is, again, just like in the previous example, if you multiply by anything over itself, that's just multiplying by 1. So we're going to multiply by something over itself, and that's just multiplying by 1. Now what we're going to multiply by is the common denominator over 1, and 4x over 1. So 4x over 1 over 4x over 1 is just multiplying by 1. And that's going to get distributed onto each piece here. So 4x times 1 is 4x. 1 times x is just x. 4x times 3 is 12x, and 1 times 2 is 2. Then on bottom, 4x times 1 is 4x, 1 times x is x, 4x times 3 is 12x, and 1 times 4 is 4. And then all of those will reduce. So 4x over x, those x's cancel, and I just have 4. 12x over 2, that reduces to 6x. 4x over x, the x's cancel, and I just have 4, plus 12x over 4 is 3x. Neither of these can reduce. They can't, if I factored the top, even if I factored it, it would be 2 times 2 minus 3x. And there's still no common factors to cancel out. So this is just my answer. I think even though these problems look a little bit intimidating, they're actually easier than what we were doing before and a lot less work. So try not to shy away from those too much. They're oftentimes easier. On to the next page. We are going to practice some more of this. We're going to look at some multiplying and dividing of rational expressions, and then we'll also practice some adding and subtracting. So in this first example here, I have some monomials, and those are terms with, or polynomials with just one term. So notice there's no addition or subtraction in any of this. These are all just being multiplied and all just being multiplied. So all I need to do is factor and reduce as much as possible. The only thing we really need to factor here are the numbers, and even that we really don't need to factor, we just need to reduce them. So I can factor or reduce anything from the top and bottom here. So for example, 15 and 25 both have a common factor of 5, 25 divided by 5 is 5. 15 divided by 5 is 3. Here, 14 and 16 have a common factor of 2. 14 divided by 2 is 7, and 16 divided by 2 is 8. And now on top and bottom, as far as the numbers go, there are no other common factors. So on top, 7 times 5 is going to give me 35. And on bottom, 3 times 8 is 24. So that is the number portion of this. The variable portion is pretty similar. On top I have a squared, and on bottom I have 1a. So I can cancel out a single a, and I'm left with 1 on top. The b's, I have 1b on bottom, and I have 3 on top, so I'll be left with 2 on top, so b squared. The x's, I have x cubed on top and x to the 5th on bottom, so there will be 2 x's left on bottom. And I have 1 y on top and 2 on bottom, so there's 1 y left on bottom. And that's it. That's the whole problem. And it looks kind of unfinished because it's 2 different colors, but really it's just the same. It's just all one answer. Now the next one is kind of a mix of those things. I do see some addition and subtraction signs, but I do also see some monomials. So what we want to do in each of these pieces first is factor them as much as possible. So this first one, 4a squared x minus 3a squared, they both have an a squared. So factoring that out, I'm left with 4x minus 3. And on the bottom here, 2by plus 5b, they both have a b. And then I'm left with 2y plus 5. And the second one here, 2b cubed y plus 5b cubed. They both have a b cubed. And I'm left with 2y plus 5. And on the bottom here, I have 4ax minus 3a. They both have an a, and I'm left with 4x minus 3. And now we can see what's ready to cancel out. A 4x minus 3 and a 4x minus 3. A 2y plus 5 and a 2y plus 5. I have an a, and we'll have 1a left on top. And then I have a b on bottom, and we'll have 2 b's left on top. And you'll notice there's actually nothing left on bottom. It's essentially like having a 1 on bottom, and dividing by 1 doesn't mean anything. It's just the same answer. So here we have a and b squared. And that is our whole answer. That's all that's left. Now in the next example, you can see that we have 4 different quadratic equations here that we're going to have to factor. So essentially this problem has 4 separate x methods within it. So again, you're seeing how important it is that you are able to factor. So again, if you're feeling not confident in that yet, make sure to go back to the previous video and really make sure you nailed that down. I'm going to color code this because I think it's kind of helpful. I'm going to do this top one in pink. X squared minus 11x plus 28. I'm going to go ahead and show my work for this one. I'll do all of the x methods and I'll show all of it. So thankfully, the a value is 1, which means there's no taking out the trash step. A times c is 28, and my b value is negative 11. The things that multiply to 28 are 1 times 28, 2 times 14, and 4 times 7. Negative 4 and negative 7 multiply to positive 28 and add to negative 11. So this one factors to x minus 4 and x minus 7. The other top one I'm going to do in green. And you'll see me organize things like this frequently. You're certainly welcome to color code your work as well, even on exams, quizzes, things like that. I don't care if you use different color pens or whatever, but if you still prefer to just use, a single color or just pencil or whatever, you're welcome to do whatever you're comfortable with. A times c, 1 times 10 is 10. My b value is 7. 2 times 5 multiplies to 10 and adds to 7. So x plus 2 and x plus 5. In blue here, I'll do the bottom left one. A is 1, C is 42. 1 times 42 is 42. My b value is negative 13. 7 times 6 is 42, so negative 7, negative 6 multiplies to 42 and adds to negative 13. So that will be x minus 7 and x minus 6. And then this last one, notice here that it's in the opposite order. I have 20 minus x squared. Well, I'm going to do this kind of off to the side here real quick. 20 minus x squared. If I reorder that to negative x squared minus x plus 20, I have a negative on my leading coefficient there. And so what I'm going to do is I'm going to factor out a negative 1. And then I'll have x squared plus x minus 20. And I think that that will be really helpful, factoring out that negative 1 and reordering it in your factoring. So let me go ahead and just put a little orange dot there. Let's go ahead and factor that. My a value is 1, c value is negative 20, so negative 20. My b value is 1, 5, and negative 4. Multiply to negative 20 and add to positive 1. So here I need to make sure I put that negative 1, and then x minus 4, and x plus 5. And from here we can go ahead and start canceling factors. I have an x minus 4 and an x minus 4. I have an x, plus 5 and an x plus 5. I have an x minus 7 and an x minus 7. And I think that's it. There's nothing else left. So my answer then is just what is remaining. On top, all I have is an x plus 2. And on bottom, I have an x minus 6 and a negative 1. So negative 1 times x minus 6. You could leave it like that, or you could distribute the negative 1 if you wanted to. Let's do another one. Here we are dividing, and again we have these monomials here. So similar to the first one we did, all I'm going to do is flip the second fraction and then follow the same process. So I have 4x squared y cubed over 15a squared b cubed times, and flipping that second fraction, now we have 5a cubed and b to the 5th on top, and 6xy on bottom. And now I can go ahead and start canceling things out and reducing. 15 and 5 reduce, and this becomes a 3. And I'm not sure if you can see that pen very well, so let me switch to another color here. 3, and we'll go ahead and cancel those out. 4 and 6 have a common factor of 2. This becomes a 3, and this becomes a 2. And there's nothing else as far as the numbers go to reduce. So on top, that leaves me a 2, and on bottom, 3 times 3 is 9. As far as the variable portions here, I have x squared on top and x on bottom. So there's one x left on top. I have a y on bottom and y cubed on top, so there's 2 y's left on top. I have an a squared on bottom and an a cubed on top, so there's 1 a left on top. And I have a b cubed and a b to the 5th, so there's 2 b's left on top. And that's it. So it looks a little weird. I'm going to go ahead and rewrite this a little bit nicer here. And we have 2xy squared ab squared all over 9. Now the next one is similar to the second multiplication one we did. Actually I take that back. It's similar to number 3, where we have a bunch of x methods to do. And I think for the sake of time, because this video is getting a little bit long, I'm going to skip over number 6. If you're looking at your notes in front of you, that one's just going to take us quite a bit more time. I don't want to make this video too long. So we'll do that one together in class. First thing I want to do is I notice that this one is again like the previous example where it's in the opposite order. So if I reorder that, negative x squared plus 2x plus 8, and I factor out that negative 1, then I have x squared minus 2x minus 8, and then I want to factor that. And I'm not going to show the x method for all of these. I did for the multiplication one, but for these, to save time, I'm just going to go straight to writing it out in factored form. So that negative 1 out front and factored would be x minus 4 and x plus 2. I will still color code things here. This top one here is x squared minus 11x plus 28. And I think I actually made these a lot or almost the same as the previous example just to kind of make it easier. So this one is the same as one of the previous ones, x minus 4 and x minus 7. And then here this is going to be, oops, I need to change colors here, x minus 7 and x plus 6. And then over here, same as before, x plus 2 and x plus 5. Now remember, when we are doing these problems, we want to flip the second fraction and change the problem to multiplication. So I'm not even going to write the first one first. I'm going to write this one first to make sure I remember to flip it. So what's on bottom becomes on top, x minus 7 and x plus 6. And then on top becomes the bottom, x minus 4 and x minus 7. And then copying the rest of it down, negative 1 times x minus 4 and x plus 2. And then over here, x plus 2 and x plus 5. So now it's just a matter of reducing. We have an x minus 4 and an x minus 4, an x minus 7, an x minus 7, an x plus 2, and an x plus 2. And that's it. So our answer then is negative 1 times x plus 6 over x plus 5. And you could distribute the negative 1 if you wanted to. You don't have to. Oops, zoom out. All right, like I said, for the sake of time, I'm going to skip number 6. But again, we'll do that one in class at some point. We're going to practice now some adding and subtracting of these fractions and creating common denominators. This first example we have here, we have pretty simple denominators. I have b, a, and a times b. My common denominator then needs to have a b, needs to have an a, and we have an ab, ba, same thing. So this fraction is missing the a, so I'm going to multiply by a over a. This fraction is missing the b, I'm going to multiply by b over b. And this fraction already has ab, already has the common denominator. So this becomes 2a over ab minus 1 times b is just b over ab plus 4 over ab. They all have common denominators now. We can add them all together. Unfortunately, none of these are like terms, so we will have 2a minus b plus 4 all over ab. Now the next one, we need to factor the denominators. They're not just single terms like the previous one. Here, the common factor is a, and then I have a minus 5. Here, this is a difference of squares. That's going to be a plus 5 and a minus 5. So my common denominator needs to have an a, the single a, needs to have the a minus 5, and it needs to have an a plus 5. So this first fraction is missing the a plus 5. So we can multiply the first fraction by a plus 5 over a plus 5. And the second one's just missing the a, so we're going to multiply by a over a. Now, I'm not going to show my work for the box method, but I'm going to multiply this a plus 5 and a minus 3 out using the box method. Again, if you want to go back to that video to refresh how to do the box method, you can. A plus 5, a minus 3 becomes a squared plus 2a minus 15 all over a times a plus 5, a minus 5. Plus, and distributing the a here, that becomes a squared minus 9a all over that common denominator, a plus 5 and a minus 5. And you don't need to multiply out the common denominators. In fact, all the way to your answer, you can leave those factored. You don't need to multiply those out. We have to multiply the top because we have to be able to combine like terms. So here I have a squared plus a squared is 2a squared. 2a plus negative 9a is negative 7a. And negative 15 plus nothing is just negative 15. And then on bottom we have a times a plus 5 and a minus 5. And this is one of those cases where we can factor the top, and you might not notice right away, so you might just have to try it and see if it's factorable. 2 times negative 15 is negative 30, and negative 7, that gives me negative 10 and 3. Those multiply to negative 30 and add to negative 7. 2a minus 10 and 2a plus 3, taking out the trash, and we have a minus 5 and 2a plus 3. Now I see right away with an a minus 5 up top and a 2a plus 3, we do in fact have a common factor that we would need to reduce. So if this is a problem on your homework or a quiz or an exam, you would need to reduce this one. We would then have our final answer is 2a plus 3 over a times a plus 5. Next example, and this is just a good time to remind you because I know we're doing a lot of complicated problems pretty quickly. You might be pausing, the video, rewinding, going back, watching the example again, and that's kind of the nice thing about having the lectures recorded this way. You can kind of pace yourself however you need to. But this is just a good time to remind you that if you're having questions when you're watching the videos, put a sticky note or write it in the margin or something, write it down, and then bring it to class. That way you remember what your question was on that particular problem. That way I can answer those questions that you have, because if you don't write it down, it's more than likely you'll forget what the question was. So yeah, just a reminder to, if you have questions, or if maybe we're doing this problem, there's a step that you didn't understand or you wanted to go over again, just write it in the margin or put a sticky note and ask me during class or office hours or whatever. Next example here, we want to factor all our denominators. Here, x minus 4, already factored, x plus 1. I just need to factor this one, and without showing my work for the x method, that would be x minus 4 and x plus 1. So my common denominator needs an x minus 4. It needs an x plus 1. And it has the x minus 4, it has the x plus 1, so that's already good. So this bottom one already, or the last one already has the common denominator. The first two fractions just have each a missing piece. This one needs the x plus 1. This one needs the x minus 4. And again, I know I'm squeezing those in real small. We're just putting the missing factors there. So this, distributing the 2x to the x plus 1, that becomes 2x squared and plus 2x over x minus 4, x plus 1, minus x minus 1 times x minus 4. You need to do the box method or FOIL. I'm not going to show my work for it, but that's going to give us, actually I'm not going to put that in parentheses, x squared minus 5x plus 4. And on bottom just that common denominator. And plus 2 over x minus 4 and x plus 1. So we have our common denominator. And we just need to combine like terms here. I have 2x squared minus x squared, gives me just 1x squared. I have 2x minus negative 5x, and a negative times a negative will give me a positive. Remember, this negative here applies to everything in the numerator. So 2x plus 5x is 7x. And there's no constant here. Negative times 4 is negative 4. Negative 4 plus 2 is negative 2. Here, this numerator is not factorable, so it's just in its simplest form here. If you didn't know it wasn't factorable right away, you'd need to try the x method and you'd see that there are no factors. These last two here, we have two examples left. I'm just going to skip number 10 this time. Again, for the sake of time, this video is getting a bit long. We'll go ahead and do number 11 and we'll do number 10 together in class. So here I have 4 denominators, technically. 5 is the same thing as 5 over 1. So my common denominator there is, or my denominator there is just 1. And then x, 3, and 2. So my common denominator is going to be 3 times 2 is 6 times x, 6x. So I'm going to multiply on top and bottom by 6x over 1 over 6x over 1. 6x times 5 is 30x over 1. 6x times 1 is 6x over 1 times x is x. 6x times 1 is 6x. 1 times 3 is 3. 6x times x is 6x squared. And 1 times 2 is 2. Each of those reduce. 30x over 1 is just 30x. The x's cancel, and I have plus 6. On bottom, 6x over 3 is 2x minus 6 and 2 reduce to 3x squared. I could factor the top and bottom, but there's nothing that would reduce. So if you wanted to factor them, you could, but nothing would reduce, nothing would cancel. So you can leave it like that. And that's going to go ahead and be the end of this video, and we will pick up with part 6 in the next video.